All right, chapter 5 is a chapter on rational functions, and that deals with asymptotes. Now, we touched upon those briefly in chapter 1 when we talked about function basics, but we're going to go a little bit more in depth here. So, first of all, this video is going to be focused on vertical asymptotes, and our next video will focus on horizontal asymptotes. So, vertical asymptotes, or again, we refer to these as VAs, okay? So we know that we can always put a function into our calculator and graph it, and then just by inspection we can see that there appears to be a vertical asymptote here at x equals 3. A reminder, this is represented by a dotted line. That dotted line is not part of our function. And so this we said is really a boundary line. As this function gets closer and closer to 3, it is going to approach this line of x equals 3 but never cross over it. Okay, but our focus here is not to be able to just look at the graph and find it, or the table of values. And again, if you were to look at the table of values for this function, you would see that when x is equal to 3, y is undefined. So instead, we are more interested in, well, how do I know that this vertical asymptote is at 3? In other words, how can I just look at this equation and within a few seconds have my answer? Well, hopefully you're thinking, well, to get x equals 3, I could just set the denominator equal to 0 and solve. So let's write that down. That's exactly what it is. So it really is not complicated at all. The process is going to be the same for all of these functions. All right, and again, these are called rational functions because you have a function divided by a function. So to find our vertical asymptotes algebraically, so we're not going to be looking at a graph. If we're only given the equation, to find a VA, you're simply going to set the denominator equal to 0 and solve for x. We do not care about what's up top in the numerator. It's not going to have an effect on where our vertical asymptote is. So let's look at some examples. Okay, here are 3 examples where we are looking to find the equation of the vertical asymptote. Now remember, since the vertical asymptote is a vertical line, its equation is always going to be x equals some number. Okay? It's never going to just be the number. You need to make sure you always express it as x equals. So in our first case here, our first example, again, the process is simple. We don't care about the top. We're just going to set the denominator equal to 0 and solve. And when we do that, we get x equals 1/2. So without even graphing this, we know that at x equals 1/2, we would have a vertical asymptote. Okay. Example number 2. Again, we can ignore that 2x plus 5 up top. We're just going to take the 3x plus 6 in the bottom. We're going to set it equal to 0. And we're going to get x equals -2. That's where our VA would be. Okay. And our last example here, we have this function that, if we look at this 4 over x minus 3, we have that function with a 2 added on here at the end. So if we were to just focus on this 4 over x minus 3 piece, we know that we would have a VA at x equals 3, right? Because you would take that denominator, set it equal to 0, and you get x equals 3. Well, what effect does this plus 2 have on that function? Well, we're really talking about a transformation here where we're taking this graph and then just shifting it vertically up 2. So let's think about if we were to graph this original function of 4 over x minus 3, we would have over here at 3, we would have our VA. Okay, so if we were to look at the graph of this, it's going to be something like this. Okay, so if I were to take that graph, all right, this is a graph of just y equals 4 over x minus 3. If I were to take that and then shift it up 2, the VA is not going to change, right? This vertical asymptote is still going to be at x equals 3. So having a number on the end like that, whether you're adding or subtracting a number, that number on the end we know is going to shift a graph vertically. That is not going to affect the VA. Now, if we were to shift a graph horizontally, yeah, the VA is going to change. But in this case, just adding or subtracting a number on the end, that is not going to change your VA. So once again, all we care about is what is in the denominator.